Ever wondered how a simple hourglass can measure time so precisely? Join us as we delve into the fascinating mechanics and design of this timeless timekeeper. To hourglasses, a timeless timekeeper. The hourglass, one of the oldest timekeeping devices, was invented over 2,000 years ago. Initially used to time speeches in the ancient Greek Senate, it remains a symbol of precision and simplicity. An hourglass consists of two glass bulbs connected by a narrow neck that regulates sand flow. This design element is critical for measuring time accurately. The grain size and texture of the sand are crucial for the hourglass's accuracy. Variations like colored or specially treated sand are used for aesthetics but must maintain consistent flow. Gravity plays a significant role in how hourglasses function. The consistent pull of gravity ensures that sand flows steadily from one bulb to the other. The size of the aperture between the bulbs determines the flow rate of the sand. A narrower aperture slows the flow, extending the time measurement. Hourglasses are calibrated to measure specific time intervals, like an hour or a minute, by adjusting the bulb size and sand amount. This precision makes them reliable timekeepers. While modern clocks offer continuous time measurement, hourglasses segment time into distinct intervals, providing a tangible representation of elapsed time. Beyond its practical use, the hourglass symbolizes the passage of time and life's fleeting nature. It remains a powerful icon in art and culture. The hourglass endures due to its simplicity and reliability. Its ability to measure time without needing electricity or complex mechanisms keeps it relevant. What are your thoughts on this timeless device? Let me know below. Anatomy of an hourglass, bulbs and aperture. An hourglass consists of two glass bulbs connected by a narrow tube. This simple yet effective design allows sand to flow from the top bulb to the bottom, using gravity to measure time. The bulbs are often made of glass, but other materials can be used for artistic designs. Inside the hourglass, sand acts as the medium for time measurement. The texture and grain size of the sand can significantly affect its flow rate. Some hourglasses use colored or specially treated sand to enhance their aesthetic appeal while maintaining consistent flow. The aperture size, or the narrow tube connecting the bulbs, is critical for controlling the sand flow rate. A smaller aperture slows down the flow, extending the time it takes for all the sand to pass through, while a larger aperture speeds up the process. The size of the bulbs determines the amount of sand they can hold, directly impacting the duration the hourglass can measure. Larger bulbs accommodate more sand, allowing for longer time intervals, while smaller bulbs are suitable for shorter durations. To ensure accuracy, hourglasses must be calibrated. This involves adjusting the sand quantity and aperture size to match the desired time interval. Calibration is crucial for maintaining the hourglass's precision as a time-measuring tool. Hourglasses have been used for centuries, from timing speeches in ancient Greece to being symbols of mortality. Over time, their design evolved, but the fundamental principles of sand flow and gravity remain unchanged. Today, hourglasses are crafted in various styles, sometimes using unconventional materials for both the bulbs and the sand. Despite these modern adaptations, the core mechanics of an hourglass continue to captivate us with their simplicity. Beyond its practical use, the hourglass symbolizes the passage of time and life's transient nature. Its image is universally recognized, reminding us of both time's continuity and its inevitable end. What are your thoughts on this timeless symbol? Let me know below. The role of sand, grain size, and flow. In an hourglass, the sand is more than just a filler. It's the key component that determines the timing accuracy. Its flow through the narrow passage is precisely what measures time. The size of the sand grains plays a critical role in the hourglass's accuracy. Smaller grains flow more smoothly and consistently, while larger grains can cause irregular flow and timing errors. The texture of the sand can affect how it flows. Fine, smooth grains ensure a steady flow, while rough or irregular grains can create blockages or uneven flow. Some hourglasses use specialty sands, such as colored or treated grains, to enhance visual appeal without compromising flow consistency. These sands are designed to maintain a uniform flow. Calibrating an hourglass involves several steps to ensure timing accuracy. Select the appropriate grain size and texture. Adjust the aperture for a controlled flow rate. Test and adjust as necessary to achieve the desired timing. The shape of sand grains also influences flow. Round grains minimize friction and flow more freely, while angular grains can cause clogging and inconsistent timing. The quantity of sand in an hourglass is crucial for its function. Too much sand can slow the flow and extend timing, while too little can speed it up, affecting accuracy. Gravity is the force that drives sand from one bulb to the other. It ensures a consistent flow, but can be influenced by the sand's properties and the aperture size. Understanding sand's role in hourglass mechanics is fascinating, isn't it? What are your thoughts on the precision of these ancient timekeepers? Share your insights below. Gravity's influence on time measurement. Gravity is the driving force behind the hourglass's function. It pulls the sand from the upper bulb to the lower one, dictating the flow rate. Without gravity, the sand wouldn't move, making it impossible to measure time accurately. The shape of the hourglass bulbs affects how gravity acts on the sand. Narrow bulbs can restrict the sand's movement, while wide bulbs allow for a faster flow. This relationship is crucial for precise time measurement. The aperture size in an hourglass is key to controlling sand flow. A small aperture slows the flow. A large aperture speeds it up. Precise aperture size ensures accurate time measurement. The size of the sand grains also impacts how gravity influences flow. Larger grains may clog the aperture, slowing the flow, while smaller grains flow more smoothly, enhancing timing accuracy. Calibrating an hourglass involves adjusting the sand amount and aperture size to ensure that gravity pulls the sand at a consistent rate. This process is essential for achieving accurate time intervals. Let's see gravity in action. Observe how tilting the hourglass changes the flow rate. The angle affects the gravitational pull on the sand, altering the time it takes to pass through. In different gravitational environments, such as space, an hourglass would function differently. Without gravity, the sand wouldn't fall, rendering the hourglass ineffective for time measurement. Gravity's consistency on Earth ensures that hourglasses can reliably measure time. Variations in gravitational force, however, would lead to inaccurate timekeeping. This highlights the importance of stable gravity for hourglass functionality. Aperture size, controlling the sand flow. At the heart of an hourglass lies the aperture, the narrow passage that controls the flow of sand. This small opening is crucial as it dictates the rate at which sand moves from the upper to the lower bulb, thereby determining the timing accuracy. The size of the aperture directly affects timing accuracy. A wider aperture allows more sand to flow through quickly, shortening the time period, while a narrower aperture slows the flow, extending the measurement time. Designers must carefully calculate the aperture size to ensure the hourglass measures the intended time accurately. This involves considering the size and texture of the sand grains, as well as the desired duration. Several factors influence aperture design: sand grain size and texture, bulb size and shape, desired time measurement, environmental conditions like humidity. Historically, hourglasses were meticulously crafted to measure specific durations, such as speeches in ancient Greece. The precision of the aperture was vital for their effectiveness in these timed events. To demonstrate the effect of aperture size, we'll show hourglasses with varying apertures. Notice how the flow of sand changes, altering the time it takes for each to empty. If you're finding this useful, a quick like would be amazing. Today, modern technology allows for precision manufacturing of hourglass apertures, ensuring consistent and accurate timekeeping. This advancement keeps the hourglass relevant even in a digital age. Creating the perfect aperture is a balancing act between the size of the grains, the desired time, and the environmental effects. This delicate balance ensures that the hourglass remains a reliable timekeeping tool. What are your thoughts on this? Let me know below. Demonstrating different hourglass designs. The classic hourglass consists of two glass bulbs connected by a narrow neck. Sand flows from the top bulb to the bottom, marking a specific time interval. This design has been used for centuries due to its simplicity and reliability. The size of the bulbs in an hourglass significantly affects its timing accuracy. Larger bulbs can hold more sand, extending the timer's duration. Smaller bulbs reduce the time interval, allowing for quicker measurements. The aperture size between the bulbs controls the sand's flow rate. A narrower opening slows the flow, while a wider one speeds it up, directly influencing the time it takes for the sand to transfer completely. Sand grain size and texture also play a crucial role in an hourglass's function. Fine grains flow more smoothly and consistently. Coarser grains may cause irregular flow or blockages. Many hourglasses feature colored or specially treated sand for aesthetic appeal. While this doesn't typically affect flow, it adds a visual element that can enhance the hourglass's appeal and uniqueness. To ensure accuracy, hourglasses are often calibrated by adjusting bulb size, aperture width, or sand volume. This process ensures the timer measures the intended interval precisely. Modern hourglass designs incorporate new materials and technologies. Some use metal or plastic instead of glass. Others integrate digital elements for added precision. Hourglasses remain a powerful symbol of time and mortality. Their timeless design not only measures time, but also evokes thoughts on the passage of time and life's impermanence. If you're enjoying this exploration, consider subscribing for more intriguing insights. Calibration and timing accuracy in hourglasses. Calibrating an hourglass is crucial for ensuring its timing accuracy. Calibration involves adjusting the sand flow rate to match the desired time measurement, which can be affected by factors like sand grain size and aperture width. The size and texture of sand grains significantly influence the flow rate in an hourglass. Finer grains flow more smoothly, while larger grains may cause inconsistency, impacting time accuracy. The aperture size, or the narrow passage between the bulbs, is a key factor in timing accuracy. A smaller aperture slows the sand flow, while a larger one speeds it up, thus affecting the time it takes for all the sand to pass through. The size and shape of the hourglass bulbs also play a role in calibration. Larger bulbs can hold more sand, potentially altering the timing if not properly calibrated with the aperture size. Hourglass design variations include different bulb materials like glass or plastic, colored or treated sand for aesthetic purposes, unique shapes and sizes for decorative hourglasses. Testing involves running the hourglass multiple times to ensure consistency in timing. Adjustments may include changing the sand or modifying the aperture to achieve the desired time accuracy. Ancient hourglasses were calibrated using trial and error, often timed against natural events like the sun's position. These methods laid the foundation for modern calibration techniques. Today, hourglasses are often used for decorative purposes, but precision is still essential in contexts like cooking or games. Accurate calibration ensures they serve their intended function effectively. If you're enjoying this exploration, consider subscribing for more insights. The hourglass in modern times. The hourglass is more than a timekeeper. It symbolizes the passage of time and mortality. In modern culture, it's a reminder of life's fleeting nature, often depicted in art and literature as a metaphor for the inevitability of time. Modern hourglasses have evolved in design, using various materials and colors to enhance aesthetic appeal. Despite changes, the fundamental mechanics remain the same, with two bulbs and a narrow neck controlling sand flow. In today's world, hourglasses are often integrated with technology. Smart hourglasses can connect to apps, providing digital timing while maintaining their classic appeal. This fusion of old and new appeals to both traditionalists and tech enthusiasts. Modern hourglasses are crafted with precision to ensure accurate timing. Manufacturers carefully select sand grain size and aperture dimensions to achieve consistency. Despite technological advances, the hourglass remains a reliable timing tool. Today, hourglasses are popular as decorative items. Their classic shape and function make them appealing in homes and offices, blending functionality with aesthetics. They serve as conversation starters and add a timeless touch to any space. Hourglasses are used in educational settings to teach concepts of time and physics. They provide a tactile, visual method for students to grasp the principles of gravity and fluid dynamics in a simple, accessible way. Hourglasses are commonly used in board games and puzzles to add a time constraint, increasing excitement and challenge. They bring a tactile element to gameplay, encouraging players to race against the sands of time. Many people use hourglasses as personal timers for activities like meditation, cooking, or exercise, appreciating the quiet, non-digital countdown. This simple tool offers a peaceful way to track time without distractions. Despite technological advancements, the hourglass persists as a beloved symbol and functional tool. Its enduring appeal lies in its simplicity and elegance, capturing the essence of time in a tangible form. If you appreciate timeless designs, a like would be appreciated.